Welcome to the Explainer, everyone. Today, we're unpacking the hidden forces that dictate exactly how we react to price changes. It's funny. Have you ever wondered why you'll completely change your shopping habits for one item on sale, but completely ignore a massive discount on another? Well, today, we're literally cracking the mathematical code behind that behavior. Just think about your own trips to the grocery store. A 10% price drop on your absolute favorite premium coffee. That might make you stock up for the whole month, creating a tidal wave of demand. But a 10% drop in the price of something else? It might barely register as a ripple. So why is our behavior so wildly inconsistent? Take a look at the classic contrast between airline tickets and table salt. A slight 10% discount in airfare causes a massive 40% surge in sales. Suddenly, everyone's planning a vacation, right? But cheaper salt? That doesn't make us buy more salt. It's an absolute necessity, sure, but you really only need so much of it. That stark difference in our reaction, that's exactly what economists call elasticity. Here's our roadmap for this explainer. We're going to hit defining elasticity, the 5 degrees, point and arc elasticity, the percentage method, and finally, the total expenditure method. All right, let's jump straight into section 1, defining elasticity, the core concept. Basically, elasticity is just a formal way of measuring our sensitivity as consumers when a price tag shifts. Think of it as our degree of responsiveness. If a price changes, do we panic, do we celebrate, or do we simply just not care? That specific degree of reaction, well, that's our price elasticity of demand. Now, the formula might look a bit complex at first glance, but it really just boils down to dividing our reaction by the actual price change to get a specific ratio. You take the percentage change in the quantity we demand and divide it by the percentage change in the price itself. This gives us this neat mathematical value we call EP, and it tells us exactly how sensitive we are to that specific product's price tag. Moving right along to section 2, the 5 degrees of elasticity. Think of this as our master map. It outlines literally every possible reaction we can have, from totally stubborn to highly sensitive. We're ranging from perfectly inelastic on the far left, where demand never changes no matter what the price does, moving right through unitary elasticity in the middle, all the way over to perfectly elastic on the right, where consumers will buy an infinite amount but literally only at one specific price. When you map out those extremes, they look completely different. A vertical line means demand is perfectly inelastic. It is frozen in place while prices just bounce up and down. On the flip side, a horizontal line represents perfectly elastic demand. Here, even a fraction of a price increase causes demand to instantly flatline to zero. And sure, while both of these are pretty rare in the real world, they act as the absolute boundaries for our map. How does this translate to the real world? Well, we will always buy our necessities, even if prices jump, but we'll drop luxury purchases in a heartbeat if they get too expensive. For necessities like life-saving medicine, the elasticity is less than 1. Our demand barely shrinks when the price goes up. But for luxuries like fine jewelry or a brand new air conditioner, elasticity is greater than 1. We are incredibly sensitive to those price tags. Let's look at relatively elastic demand in action. Imagine a mere 10% price drop triggers a massive 20% surge in the quantity we demand. Notice how flat an elastic demand curve is. The gap representing quantity is visibly much larger than the price drop itself. This is your classic luxury item behavior. And then we have the exact dividing line. Unitary elastic demand. This creates a perfect rectangular hyperbola. That's a fancy way of saying a percentage drop in price triggers the exact same percentage rise in demand. If the price falls by 10%, demand rises by exactly 10%. Since they move in perfectly equal proportions, the elasticity value is exactly 1. Okay, section 3, point and arc elasticity. So point elasticity measures responsiveness at one microscopic spot on the curve, like point R. Arc elasticity, on the other hand, measures a larger, finite movement between 2 points, say R and R1. If the price change is incredibly small, like almost infinitely small, we use the point method. But if there is a significant price swing that physically moves us down the curve, we're going to measure the arc between those two distinct realities. Now, if you have a straight line demand curve, calculating point elasticity is actually a wonderfully simple geometric trick. You just divide the lower segment of the line by the upper segment. Pick a point, measure the distance down to the bottom axis, and divide it by the distance up to the top axis. It really is a brilliant, quick way to find elasticity at any exact moment. Let's transition to Section 4, the percentage method. This step-by-step proportionate method is absolutely crucial because it ensures we're looking at relative percentages rather than absolute raw numbers, giving us the true EP value. I mean, it just wouldn't make sense to compare a $10 discount on a car to a $10 discount on a cup of coffee, right? By converting our starting numbers into percentages first, we level the playing field and get an incredibly accurate picture of consumer sensitivity. And finally, Section 5, the total expenditure method. I love this one because you can think of it straight from the perspective of a business owner checking the cash register. If we just multiply the price tag by how many items we actually bought, we can track elasticity by simply seeing if a price drop brought in more total revenue or less. Let's break down the math. Notice how a price drop from 60 to 50 results in people buying more units, but our total outlay stays exactly at 600. We bought 2 extra units, sure, but because the price went down, the total money changing hands remained completely frozen at 600. The elasticity here is exactly 1. It's perfectly unit elastic. And when you translate that math visually, it's fascinating. Rectangles OA and OB have the exact same area, which completely proves that total expenditure didn't change at all. When the price dropped, the rectangle simply reshaped itself. It got shorter but wider, maintaining the exact same overall footprint on our chart. Conversely, what if a price drop causes our total expenditure to actually fall to 550? Well, then the demand is relatively inelastic, much like our table salt example from earlier. Sure, the price dropped from 60 to 50, and yeah, we bought 1 extra unit, but it just wasn't enough to make up for that lower price. So total spending actually shrank. We simply weren't sensitive enough to the sale to spend more money overall. But if the price drop entices us to spend a total of $650, which is more overall money than before, we are dealing with relatively elastic goods, like luxury items. That drop to $50, it made us jump up and buy 3 extra units. The massive surge in volume more than compensated for the discount, meaning the cash register is actually fuller than before. This is elasticity greater than 1 in action. It really makes you evaluate the hidden math behind your own shopping cart, doesn't it? But before we wrap up this explainer, I want to leave you with a final provocative thought. Elasticity doesn't just apply to price. It absolutely applies to your paycheck. Think about the income elasticity of demand. What happens to your buying habits when your income changes? First off, we have normal goods, which have positive income elasticity. Simply put, your income goes up, you buy more. Now, if it's highly income elastic, meaning greater than 1, your demand actually surges faster than your paycheck. Think of luxury items like new cars, color TVs, or jewelry. If it's income inelastic, so less than 1, you buy slightly more but not a ton. These are your everyday necessities like basic food, soap, or clothes. And right in the middle is unitary income elasticity, where the changes are perfectly equal. Then, secondly, we have inferior goods. These have negative income elasticity. This sounds wild, but if your income goes up, you actually buy less of them. Picture a consumer getting richer. They're going to drop coarse cereals like maize and bajra and immediately switch to superior grains like rice and wheats. Finally, there's zero income elasticity. This is where income changes leave your buying habits completely untouched. Think back to our textbook example of salt. You are definitely not buying more salt just because you got a salary bump. So the next time you're at the store, ask yourself, are you reacting to the price tag or are you actually reacting to your paycheck? Thanks for joining me for this explainer, and I challenge you to figure out your own elasticity.